let's see if I can change. Oh. So I'm going to just cover these 2 points today. Very simply, what is geothermal energy and the geothermal resources in Scotland? Now I'm going to focus in on what you have in Aberdeenshire and what's just below your feet as well, so you can kind of get a little perspective on what geothermal opportunities are underneath your feet right now. So what is geothermal? So it literally comes from the word geo, meaning earth, and thermal, meaning heat. So it's the heat that's generated in the center of the Earth's core. And this primarily happens through radioactive decay. And just 0.1% of this heat source could power humanity's total energy needs for the next 2 million years. However, it's nicely insulated by lots and lots of layers of rock beneath the Earth's surface. And this heat is transported to the surface through pores and permeability, which are basically fluid pathways. So it travels in fluids to the surface. And that's what we traditionally know as geothermal energy, which is volcanoes and geysers and bubbling mud pools. Now, these are called high enthalpy geothermal systems, and these are often found along plate boundaries. So if you get your eye in here, this is a map of the world, and then the plate boundaries are superimposed on top of it. And where we have active plate boundaries, which is where plates are kind of moving alongside each other, it creates this fluid pathway. So water can come to the surface containing all this heat energy. So when we traditionally talk about geothermal energy, we're thinking Iceland and the Blue Lagoon and geysers and California with these massive billowing steam clouds coming out of geothermal plants. Now, I don't know about you, but I have not seen any of this in Scotland. And Scotland, as you can see on the map, is not near any active plate boundaries. So it'd be a very good question to ask, well, what geothermal have we got right here? So a bit of background on geothermal is the first ever geothermal power plant was in 1904 in Ladarello in Italy. And currently we have 15.4 gigawatts of installed geothermal power plants globally and 107 gigawatts of thermal energy installed globally. Now this capacity could reach up to 200 gigawatts of geothermal power and 5,000 gigawatts of geothermal heat. And it's not just coming from these really obvious resources that pop up at our plate boundaries. And there's a number of uses we can use geothermal energy for. So it's not just this top 200 degrees end where we can generate electricity. All the way down to 10 degrees, we can use geothermal energy to power numerous different industries. So this includes kind of farming with aquaculture, soil warming, mushroom cultivation, and heating greenhouses. But also up for kind of heavy industry like industrial washing and distilling and making construction materials as well. So right across the board, there are uses for geothermal energy. I really like this image. This is why we need to start talking about geothermal heating. It's because it's the elephant in the room at the moment with our acceleration to net zero. I think it was, I'm going to get this wrong, but last year we provided 97% of our electricity from renewable sources in Scotland, which is absolutely fantastic. But we've still got to tackle this heating problem. And this is a global issue as well, that if we're going to reach these climate goals, we need to tackle decarbonising heating. And especially within the UK, so 45% of our energy demand is in heating, which produces 32% of our carbon emissions. And as we're kind of moving away from fossil fuels, we need to find something that replaces this really cheap gas that we use to currently heat our homes. So what are the geothermal resources in Scotland? So there are a number of geothermal resources across the board. So we start very, very shallow with ground source heat pumps, and these can be installed practically anywhere. Mine water is kind of slightly further down, and in old mining areas such as the central belt of Scotland and in North Wales and Northeast England, we have these great open holes essentially where they've mined out all this coal, and these have now flooded with water and become heated through the surrounding rock. We have hot sedimentary aquifers. These are big wholly porous rocks which hold lots of water within them to about 2 kilometers depth. And we have these again in the central belt and in the borders within Scotland. We're also looking at, when I say we, I mean the geothermal community, recycled oil wells. So,
oh, we've lost your sound.
Oh, can you hear me now? No? Now?
I think on online we can
30
still see.
seconds. We've
the
lost
last.
your sound.
Okay, can you hear me now?
So first line or out?
Yeah. Cool. Okay. So 5 main resources of Scottish geothermal resources. Is that okay?
We can hear you online, okay, Hester?
Any thumbs up from the people in the room?
Hester, we have a
progress.
Oh dear.
Oh, I'm
Oh
sorry.
dear.
We've got 2. Oh, we're
I
back.
was about to get exciting as well. Oh.
We're on. Okay, Hester, go for it. We got
Yeah?
to.
Okay.
Recycled oil well, and it was sounding
Okay.
fun.
Oil well. So repurposing oil wells is another line of geothermal, which is where you have a spent empty hydrocarbon reserve that's now full of briny water, and we can harvest the heat energy which is within that. And lastly, and most importantly to you guys, is the hot dry rocks. So this is fractured granites that are high heat producing. So I'm going to talk about specifically these today because I think they're most relevant to you guys. So hot dry rocks, these are hot radiothermal granites, which basically means it's a rock that emits more heat than the surrounding rocks. So we have a nice big reserve down in Cornwall, and we've got 2 active projects looking at deep fractured granites at the moment down in Cornwall. But as you also see from this map, we have some in northeast England, and we also have in the top right the North Grampian Highlands. And this is where Scotland's hottest rocks are. So you can see from this map on the right, the ones which are white are high heat producing granites, and then stripy is marginally heating, and then grey is low. So from our point of view, we can happily dismiss the low ones, but it's the marginally high and the high heat producing ones which are really, really exciting. So what are granites? Granites are crystalline igneous rocks. They're very, very hard, and they have absolutely no fluid flow in them. So they have no primary porosity. They're made up of several minerals, and they also contain traces of uranium, thorium, and radium, thorium, and uranium, which these are radioactive elements which decay, which can produce more and more heat. So this is why these rocks are especially hot. So I'll quickly just go over this, bear with me. It's a little bit too scientific for a Tuesday evening, but so we're talking about porosity, which is the holes in your rocks, and that allows for fluid to kind of flow between them. And because granites don't have this, what we do to get this fluid flow in the rock is we target something called secondary permeability, which are faults. So when rocks move and fold, they also break apart, which means they create big faults, which allows for this fluid flow. And this is what we can target for deep geothermal systems. And they're basically highways through the rock, so the fluid can suddenly accelerate through. So deep fractured granites, a little bit of history now. So in the 1980s, the UK did a big geothermal exploration program, and they flagged these really hot Cornish granites and said, brilliant, this is great, let's go for these. And they kind of dismissed the Scottish granites as being too cold. Then in 2005, someone published a paper, someone called Gosnod, that the last glaciation period was a lot lower than initially thought, which means the top half of the globe, the rocks are a lot cooler at the top than because of this glaciation effect. This is called the paleoclimatic effect. This was then interpolated onto our granites by 2 men called Westaway and Younger in 2013. And they estimated that our heat flow was under 20%. So we can increase the amount of heat flow predicted at depth by 20%. But this hasn't been proven yet. So we don't know what the capabilities of our granites are, because there are no boreholes beneath 300 meters on any of the granites in the northeastern Grampian Highlands. There's one on the Cairngorms, but again, that just goes to 300 meters. So this map here just shows the kind of heat production values of granites in Scotland. And if you look at the top right, it's the Cairngorm suite that's the highest heat producing. And there are a number of people looking at if it would be feasible to have a deep geothermal project in Scotland. So Townrock, my company, are working with the company that developed the Cornish geothermal sites and having a look at the feasibility for if we can pursue deep geothermal in Moray. There's a company looking at the Balmoral estate, King Charles's Balmoral estate, and they're called ZGEM, and they've completed their phase 1 feasibility study. And there was also a publicly tendered feasibility study for Cairngorm Ski Mountain, which is being completed by a company called Arup and GEL, which is Geothermal Engineering Limited. Also many years ago, well, not many, in 2017, we with a consortium of other people produced a feasibility study on the Hill of Fair granite as well. So there's numerous people that are getting really, really excited about the deep geothermal potential in Aberdeen. This is something that's currently ongoing. This is a project we're doing with a company called AstraSat, which is using satellite data to see if we can identify large fault structures from space. So as I mentioned earlier, we're targeting these fault structures for their fluid flow, for their natural fluid flow. And we're going to see if we can see these from space, which is a way of kind of non-invasively exploring for geothermal energy. So this is a project that is currently operating at the moment in the UK. This is called the United Downs Deep Geothermal Power Project. So this is focusing primarily on getting power out of geothermal energy. So in Cornwall, they do have the hottest granites, and they're able to reach about 180 degrees at 5 kilometers, which means they can produce power. In the Grampian Highlands, we're looking more at producing 130 degrees at 5 kilometers depth, 130 to 150 degrees at 5 kilometers depth. So though we're not aiming for power, we are aiming for large amounts of heat energy. So this was the first commercial deep geothermal power project in the UK. They have 2 wells. One is drilled to 5,275 meters, which is the production well, and then the injection well is 2,393 meters deep. This cost around 30 million, and it was funded by European funding, plus a little bit of local council money as well. And that's a picture of the drill rig that was used at the site as well. And this is essentially what they're doing, which is targeting this naturally permeable system. So they are producing from this bottom well at 5 kilometers, and they're bringing this hot water to surface. They're then extracting the heat, and then they're re-injecting the cold water into the same fracture system, which then trickles down and gets warmed up by the rocks and then recirculates again. So it becomes a renewable system. So I thought we'd focus in on this as a local community. So as the locals to this area, what you can expect and what your opportunities and risks are when it comes to having deep geothermal within your community. So the main point with geothermal energy is it will remain within your local economy that it's created in. You cannot, like oil, get a big barrel of it and sell it on a market. Heat cannot be transported very far at all. So once you generate that energy, it has to be used within a radius of about 5 kilometers. It is constant baseload energy, which is net zero. So it means it operates 24 hours a day, 7 days a week. It's affordable, though it has very large upfront capital costs. The operating costs for years on from that are very, very cheap, or relatively cheap and affordable. It creates inward investment. So companies which are looking to decarbonize, reach net zero goals, will be drawn into areas which can say that they have their energy run on net zero energy like geothermal. A really important point for Aberdeen is that it creates jobs, and these are very, very similar to the jobs of oil and gas. So what we can do is repurpose a lot of skills, services and tools which are used in Aberdeen right this second, and we can repurpose these for the oil and gas industry, and they're very, very similar skill sets. It also has a much smaller surface impact than solar or wind. I'll talk about the drilling in a second, but the actual, once the power plant is up and running, or sorry, the energy plant is up and running, it's got a very, very minimal surface impact. Now, with any project, there are risks and disturbances that come alongside. So the drilling, and I'm sure you saw the picture of the drill rig earlier, this can take up to 6 months, and this can cause local issues with noise, light pollution, traffic, and visual impacts. And though this is something that's written into any planning permission or any environmental considerations and regulations, it is a really important point for the local community to be communicated on that this can be an impact that is very, very temporary. It's only 6 months, and then your geothermal can last a lifetime. And the last point is induced seismicity. And this is a really interesting point where the risk is perceived to be a lot higher than the actual risk. Because we're targeting naturally permeable systems, it's not like fracking where they come in and they create fractures within the rocks. It's very much, we're not creating fractures, we're targeting fractures which are already there. And induced seismicity is natural across the world. Background seismicity, as plates like we talked about earlier flex and move, they release energy, and this is seismicity. If it reaches the surface in a big enough amount, it's called an earthquake. This, when we talk about microseismicity with a deep geothermal project, it's not felt on surface. It's very, very rarely felt on surface. So it's a risk which is managed throughout the project and monitored throughout the project, and also has limits to how much microseismicity can be created within a project. But it's something that if a deep geothermal project was to begin in Aberdeen, would be discussed with the community and with environmental agencies and planning commissions people as well. So I hope that's given you a bit of food for thought on deep geothermal in Scotland, and especially within Aberdeen. I'd be happy to take questions, but I think we're going to save these to the end.
Yes.
Yeah, Hester, thanks very much for that. That's absolutely brilliant. We will take questions afterwards. So what we'll do is we'll go straight on. We'll stop the recordings